different one? Anybody? Rogelio? Say it again. Tails and then all heads? Well, we only want 2 heads. Okay. Maybe tails, 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 heads, heads. I'm sure that was what you were. Dex, you have everyone?
HT.
HT. Any other ones? Brian?
Heads, tails, 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 heads.
Heads, tails, 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 heads. Khadijah, was that yours?
Yes.
Okay. Frida?
Heads,
Heads, tails, tails, heads, tails. Let's see. Any other ones? I think so. I got 10 when I was doing this. 1, 2, 3, 4, 5, 6, 7. Let's see what we're missing. Do we have tails? Head? We do have the heads.
Heads.
We have the tails, tails, heads. We don't have this one. No, we do. What about tail, head, tail, head, tail? We have that? No. Right, and I could keep on going. There's 9. There must be one more. Here's the last one. So, point being, you could go through this. You could list out all the different possible outcomes. And then you could ask the question, what's the probability of having 2 heads and 3 tails? Will be all of these options divided by the total. Right? That is one way to do this. That would be an incredibly long and tedious process. Today we want to find a much simpler way to do a problem like this. That's where we're going. So let's find out what that way is. So, let's look at this model problem. All right. So 2 very important topics today. So we have a model problem. It says a coin is known to be unbalanced in such a way that heads only comes up 0.4, so 40% of the time. So we know that in a regular coin, heads should come up 50% of the time. But it says this one is unbalanced. So it says the coin is unbalanced. Are you recording? Sorry. Okay, you can just record over here. I won't move on. So the coin is unbalanced, so heads comes up only 0.4% of the time. So basically the probability of heads is 0.4 and the probability of tails is 0.6. So this is unbalanced, right? A regular coin is 0.5, 0.5. Let's see. A regular coin is 0.5, 0.5. This is 0.4, 0.6. And we're flipping the coin 5 times. And then we're going to ask these questions based on this scenario. So the first one is the situation geometric or binomial? You have no idea what these words are, so let's define them.
I don't know about binomial.
So we know, so there are 2 types of probabilities. The first is a binomial probability. And there are 4 things that must be true in order to have a binomial probability. I'll explain what these 4 things are. So the first thing that has to be true for a binomial probability, the reason it's called binomial is because there are only 2 options, heads or tails, success or failure.
Yeah.
So there must be 2 options, success or failure. So, heads or tails? Rolling an odd number on a dice or an even number. There are only 2 options. If I get a 1, yes, I rolled an odd number. If I get a 2, I failed. If I rolled a 3, I'm good. If I rolled a 4, I'm bad. If I rolled a 5, good. 6, bad. Every outcome needs to either be a success or a failure. First thing. Second thing is you need to have a fixed number of trials. I'm going to flip the coin 5 times. I'm going to roll the dice 100 times. I have 100 people whom I'm going to examine. Dex?
Hold on. You talking about specifically for a coin?
No, it's not just for a coin. For any trial,
Oh, yeah.
for any circumstance,
Success or failure.
we are going to apply this to the coin situation.
Oh.
So there's only two options. You can either succeed or fail.
Because I can think like if you put tails as failure, I don't think unless you like there's a situation like
The third one, one second. So the third one is we need the outcomes to be independent So if I flip a head the first time, that has no effect on whether I flip the next time. I just flip the coin again. If I roll the dice, the next roll has no effect. I mean, the first roll doesn't affect the second one. Bless you. And the fourth one is two options, fixed number of trials. The last one is that the probability of success does not change. The probability of success does not change. So what do we mean by that? What we mean by that is the following. Right now, in this example, the probability of success is 0.4 if I want to get a heads. I have a 40% chance of succeeding. If halfway through this, somehow the coin now becomes regular, the probability of success would go from 40% to 50%. This would not apply. The probability of success cannot change. You got to have the exact same probability throughout. This is a definition of a binomial distribution or a binomial probability, and it's really good because there are very, very nice formulas to be able to use to calculate such a probability. So let's apply the formula now. So I know this example is an example of a binomial probability. And the reason I know it's binomial is what? One, there's a fixed number of trials. I'm only flipping 5 times. So this condition is met. There are only 2 options, success or failure. Success, I flip a heads. Failure, I get a tails. This is met. Number 3, the outcomes are independent. Flipping a head the first time has no effect on the second time. And the probability of success doesn't change. It appears that the coin remains unbalanced throughout the whole 5 flips. I'm not all of a sudden going to make it a regular fair coin. All 4 conditions are met. On the AP exam, if there's a free response question like this, you need to list the conditions and explain why they're all correct. Multiple choice, obviously you don't have to. On a free response question, they'll want you to see the 4 sort of reasons, and they're going to want you to show that those are correct. Okay, so that's part A. So this is a binomial distribution. So now, how do we actually apply the formulas? Well, on your formula sheet, did you guys get a chance to pick that up today? You walked in the formula sheet. Some people may already have that. I wanted to provide another one. I'm going to start referring to this more. I'm also going to get a poster printed of the sheet, 3 posters, 1, 2, 3 on that wall, so we can have it up there, be easier to reference. If you go to page 2, which actually has a 4 on the bottom, and it says if x has a binomial distribution, about halfway down, middle of the page, those are the formulas we're going to be using today. The one where it says if x has a binomial distribution. So let me start there. So number 1 says the following. What is the probability that we have heads exactly 3 times? So I flipped 5 times. I want to know what's the probability of getting exactly 3 heads. If you look at your formula sheet, it says, so if I'm over here, is it going to pick up?
No.
The probability that x equals some number k is equal to, and this looks very strange, but we'll explain exactly what this means. So this is what we have up here. If you look at the formula sheet, it says that's the probability if it's a binomial distribution. So what the heck does this mean? probably a lot of people are unsure. Well, let's find out. The N is the number of trials. Number of trials. N is the number of trials. K is the number of successes. So let me first label, then we'll apply it to this problem. K is the number of successes. Spelled wrong. X, of course, is just the random variable. Successes. That's spelled wrong.
Why do you spell like that then?
Because I don't exactly know how to spell it. P is the probability of success. And we talked about N again. So let's make sure we get these down. If you want to write them on the formula sheet or in the notes, that's your choice. Of course, on the AP exam, you won't have your notes on the formula sheet, but for right now, I think it's not a bad idea to have it on there. Okay, so let's apply this to this problem. So in this problem, we're saying, what is the probability that x equals 3? Because we want to know what's the probability that it comes heads, or that I succeed 3 times. So the probability that x equals 3 is equal to this little parentheses thing, which again, I haven't explained what this means yet. We will get there. 5 is n, because it says I'm going to flip a total of 5 times. K is 3. I want 3 successes. The probability of success is 0.4. K, of course, is 3. And then 1 minus 0.4. 1 minus 0.4 raised to the n 5 minus k. So to the 5 minus 3. So let's simplify a little bit. Let's simplify a little bit. Probability x equals 3. I can't really do anything here yet.